This is the video review for properties of logs and graphing. And so we're going to start off with change of base formula. So just generally, before we actually do any of these problems, I just want to remind you that if you get any problem and it says something like log with a base of b, and the number that we're taking the log of is a, that you can turn that into the form log of a over log of b, right? And so what this means when we just say log without the base, it's log of 10. Which means we'll be able to use our calculator. So as an example, problem number 1, we're going to just do the log of 8 over the log of 4, right? So before I even calculate any of these, okay, I'm just going to set up all of them. So again, problem number 2 says the log of 10 over the log of 3, right? The third problem, right, says the log of the number, 14, over the log of the base. So I'll just do these three. You can see that these three down here are pretty much the same thing, so we don't need to repeat ourselves 6 different times. Right? So before we actually calculate these, we want to be in the habit of just predicting what we think it should be. Right? So if I'm looking at log base 4 of 8, really what I'm asking is 4 to what power gives me 8? And if I think about the powers, 4 to the first power gives me 4. 4 to the second power gives me 8. I'm sorry, 4 to the second power gives me 16. And 8 is somewhere between 4 and 16, which means I should expect the answer to this, the exponent, to be somewhere between 1 and 2, right? So if we pull up the calculator now, I'm going to type in log of 8 divided by log of 4, right? So let me bring up my calculator. I'm going to type in 8 and hit my log button. Okay, so there's the log of 8, and then I'm going to divide that by the log of 4. Right, and there's my answer, 1.5, and if you notice, 1.5 is exactly where we predicted it would be. It's right between 1 and 2, right? So for these other problems, I'll just do one more calculation. Again, I'm going to do log of 10, so I'm going to hit 10 and hit my log button. And again, you might need to do it the other way around and do log and then hit 10, okay? And then I'm going to divide it by 3, right, and hit log, okay? And before I hit the enter button here, let's just do a prediction, right? 3 to the first power is 3. 3 to the second power is 9, right? And so that's still below this value of 10, right? And then 3 to the third power is all the way up to 27, right? So I should expect the log base 3 of 10 to be somewhere between 2 and 3, and probably really close to 2 because 3 to the second is 9, and we're only going slightly above that, right? So I should expect something really, really close to 2, and you can see that my answer comes out to be 2.09, which is really, really close to 2, right? That's what we're looking for. So this change of base formula can be used in any of these problems where you can't, in your head, to calculate the value where you have to do this estimation. We can now use the change of base formula to do the calculations using the calculator because it knows about base 10, okay? So moving on to problem number 7, it's asking us to find the inverse of this g of x, right? And so remember what inverse meant. First of all, we're going to get rid of the g of x, and we remember this can be the same as y. We can call it anything we want, right? And the inverse said switch domain and range. So the first thing I'm going to do is rewrite this as x is equal to the log base 4 of y minus 4 plus 2, right? And then we want to try to get y by itself again. So this y in here needs to be by itself, so the very first thing I need to do is get the container of y, which is the log expression, by itself, by subtracting the 2 over. So I'm going to say x minus 2 is equal to the log base 4 of y minus 4. And so now we have to figure out, how do I get this y out of its container? How do I make the log go away? Right? And the way that we do that is we just do a conversion to exponential form. So this is a base, this is an exponent, and this is what comes out. So I'm going to rewrite it in that exponential form, and this should say now 4 to the x minus 2, okay, is equal to y minus 4. And then to finish this off, I need to get y by itself, so this 4 that's on the right now needs to be added to the left. 4 to the x minus 2, and then I'm going to add a 4 onto that, and that equals y. So the inverse, right, which sometimes you might not see y, we might replace this with g was my original expression, so you might see it written as g inverse of x. So this expression right here is the inverse, okay? So now what we're going to do is we're going to take the original function, and so you have to be careful, right? My original function is g of x, right? So it says graph g of x, so I'm not graphing the inverse, I'm not graphing that exponential we just found, I'm actually graphing the original function, right? So before we ever get to that, I'm actually going to come down here, Okay, and I'm going to answer these questions because we'll be able to use them to help us with the graph. So we don't have to do test questions in order. So I'm actually going to bring this function down a little bit so we can use it to answer these questions. So the first question says, what is the domain of this log function? And so what you need to remember is that inside of a log function, which for us is the x minus 4, so I'm just going to bring this down. This is the important part, x minus 4. It is not allowed to be 0. It is not allowed to be negative. So we need to make sure that this expression stays greater than 0. And so when we solve this, it's just going to say that x is greater than 4. That's our domain, right? So I'm going to say x has to stay bigger than 4. And again, this kind of makes sense because if I were to plug in, for example, 0, which is smaller than 4, I'd get the log base 4 of negative 4, and we're not allowed to do that, right? That's a problem, okay? All of our log functions, the range is everything. Okay? It's going to go up and down forever. The asymptote is going to be off of this x value. There's a restriction on the domain here, so it's actually going to cause an asymptote to happen at x is equal to 4. Okay, and so now we just have to figure out this x-intercept. The x-intercept is one we actually got to calculate. So let me give myself a little space so I can calculate. Okay, x-intercepts, and this is true of all functions all the time. In every x-intercept, the y value is 0, and remember that's what we're calling g of x here. So 0 equals the log base 4 of x minus 4 plus 2, right? We're trying to figure out what is x when we make y 0. That's the definition of what an x-intercept is. So I'm going to take this 2 and I'm going to subtract it over to the right, so it becomes negative 2. Right? Log base 4 of x minus 4. Okay? And now I'm going to do my change, right? I'm going to turn this into exponential. 4 to the negative 2. Right? 4 to the negative 2 is equal to x minus 4. And then I'm going to use the calculator, and we're going to just turn this into a decimal, which you can leave it as a fraction. It's 1 over 16, right? But if we want to turn this into a decimal, we can say 4 to the negative 2, and 4 to the negative 2 is 0.0625, right? And then so I'll do the conversion, 0.0625, okay, equals x minus 4. And then I'm going to add 4 to both sides, and it's just going to become 4.0625, right? And this is my x-intercept. So I'm claiming if we go to 4.0625, comma 0, that's where this graph should cross the x-axis, okay? So now let's take what we know about the function, all of these questions that we just answered, right, and let's go up and actually do the graph, okay? So I'm going to come back up here. Let's bring g of x up, okay? And we're going to just make a table of values, right? So I'm going to just make an xy table. And we need to pick x values, and we want to try to be careful about what we pick. Let me draw that straight line. That's going to bother me. So we're going to say, let's think, okay? What are good values to put in here? Well, the first thing we saw was that the domain says that we have to put in things bigger than 4. So let me just put in something at the very beginning of the domain like 5, right? See what happens there, okay? The other things that I want to put in for x are things that are going to make this expression turn into a 4 to the power, right? So for example, 4 to the 0, 4 to the 1, 4 to the 2, right? Those would be nice numbers to have here. So, for example, 1, right? That's 4 to the 0. That happens when I plug in the 5. That's good, okay? When I plug in, put a 1 here, I get 4. So how can I make a 4 happen here? Well, it looks like I want to plug in an x value of 8, okay? And then it looks like I'm starting to get to the end of my graph. My graph only goes up to 10, so I'm just going to plug in 10. So let's see what happens with these 3 points, okay? So when I plug in 5, here's what I get. The log base 4. 5 minus 4 is 1 plus 2. And be careful, this has got to all be done first before I add the 2. So the log base 4 of 1 is 0. 0 plus 2 is 2. Okay? Problem number 2 says the log base 4 of 8 minus 4, which is 4. Okay? So when I do this, I get 1 plus 2, which is 3. And then 10 is kind of a trickier one. When I plug in a 10 here, I get a 6, right? The log base 4 of 6, and then I got to add 2 to that. So this is a problem where I don't know just in my head what the log base 4 of 6 is. So that's why we just did problems where the change of base formula comes in. So if I go to my calculator, type in the log of 6 divided by the log of 4, that's how I'm going to figure out these more irregular ones. So if I go 6 and hit the log button, and I divide that by 4 and hit the log button, I get about 1.29, and then I need to add 2 to that, so it looks like 3.29. Okay, so I have 3 values, right? I'm going to draw myself my asymptote. We already did that too. Okay, so I guess we'll just go with the red. Okay, and down here again, we said the asymptote was at x is equal to 4. So I'm going to go over to x is equal to 4. Well, that's right here. Okay, and I'm going to draw a wall here. That's what the asymptote really is. We're saying there's this line, and the graph will not pass through that line. All right, so I'm going to start graphing my points now. Hopefully they are all greater than, or they're all on the right-hand side of this line. So 5, comma 2, that's this one. Okay, 8, 3. Right, and then 10 was 3.26, which is just a little bit bigger than 3. Okay, so this is where it gets important. You need to understand what this is going to look like. So the asymptote means that it's, we're obviously going to travel to the right. Okay, and it's not going to go through here. This wall means it's going to kind of get close, and then as it gets close, it's going to start turning, and it's just going to ride right along the line. So let's see if I can kind of draw an accurate graph with my computer pen here. Okay, so it's kind of riding right along the thing. It's never going to go on the left-hand side of that line, and it's going to head down forever. So that would be an accurate graph, right, using all the information or most of the information that we got down here. And the last thing we can do is we can actually confirm now that our x-intercept makes sense. Right? You can see where this crosses the x-axis is at just a little tiny bit to the right of my asymptote, which was at 4, and we're claiming 4.0625. That makes a whole lot of sense. It's just a tiny bit bigger than 4. And it should be because it's really close to the asymptote. Okay, so problem number 10 is very similar. I'm going to just run through this one a lot quicker. So again, the idea for inverses is switch x and y. So it'll say x equals a half log base 4 of 2x minus 4 plus, or 2y minus 4 plus 2. Okay, and now I'm going to subtract the 2 over. Okay, x minus 2. And then to get rid of this 1/2, I want that to be gone, so log is by itself. I'm going to multiply both sides by 2. Which is the same thing as dividing by 1/2. So when I multiply both sides by 2, there's going to be kind of a 2 sitting out front of this. Okay, and so that will get rid of the 1/2 and the 2 that are making it so our log is not isolated. Okay, I'm sorry that my 4's and my y's look alike. We'll try to be careful with that. Okay, so now that I have this set up, I'm going to turn this into 2x minus 4 as we go. I'm going to say base exponent. And then this is what should come out. So I'm going to say 4 to the, remember this is really 2x minus 4, so I'm going to distribute 2x minus 4. Okay? And this equals the output, which is 2y minus 4. Okay? So now the rest of the problem is just getting y alone. So let's add the 4 over. Okay? So it'll be 4 to the 2x minus 4, okay, plus 4, and that equals 2y. And now we got to decide with this 2y. So technically you could go like this. But that is not standard form, so we're not going to do that, right? And the question keeps coming up, will that be marked wrong? No, it won't, but it's not standard. We can simplify better than this, okay? So instead what we're going to do is we're just going to multiply by 1/2, right? And that means that I need to multiply both of these expressions in the plus problem by 1/2. So the exponential I cannot, and this is where people make mistakes, I cannot multiply this 4 by 1/2 because it's got an exponent, and I need to do exponents before I multiply. All right, so I'm just going to actually leave this as 1/2 times 4 to the 2x minus 4. But I can multiply the 1/2 by this 4, which would just make it 2. Okay, so in simplest form, or standard form, this expression right here, half times 4 to the 2x minus 4 plus 2, would be the inverse of g of x, which again you might see written as g with the little -1, which means inverse. Okay, so again I'm going to come down here. Here's your domain. Hey, domain is when is 2x minus 4 greater than 0? Well, that looks like when x is greater than 2, right? So you can solve that. X is greater than 2. Okay, the range is always everything. Okay, the asymptote is the same value as the domain, but we're going to say the line x equals 2. Okay, and then to find the x-intercept, hey, we're going to take this expression. Let me move it down so I don't have to keep moving up and down again. Okay, I'm going to take this and I'm going to say, let's set it equal to 0 and solve and see what happens. Okay, so I'm going to say 0. Get a good color. Purple looks good. Okay, 0 equals 1/2 log base 4 of 2x minus 4 plus 2. So I'm trying to find out what does x have to be so that y will be 0. Or so that y will be 0. Right, so again, same idea. I'm going to isolate the log, so subtract over the 2. -2 is equal to 1/2 log base 4 of 2x minus 4. Okay. And then multiply both sides by 2. That will get rid of the 1/2. Okay, so that's going to be -4 because I multiplied by 2. And then this is canceled, so log base 4, okay, of 2x minus 4. Okay, and now I'm going to do my change of, to exponential form, which this is base exponent output. So 4 to the -4 is equal to 2x minus 4. let me get rid of that. That's a typo. Okay, so we're just going to say instead 2x minus 4. Okay, and now I'm just going to finish up the problem. 4 to the negative 4 is a really small number. Okay, it's going to be 4 to the negative 4. It's a really small fraction. Okay, 0.004 about, we'll round, right? So we'll say 0.004, right, equals 2x minus 4. Okay, and now I'm going to add 4 over, which would just make it 4.004. So I'm just going to be a little lazy and skip this step. Okay, and then I'm going to divide both sides by 2. And so it looks like my final answer is going to be that if I go to 2.002, comma 0, that's a good x-intercept. Okay, so with my graph, I'm going to say, here's my table. Okay, and I'm going to just pick some values. So down there at the domain, it says, okay, that x should be greater than 2, right? So I'm going to start with the value of 3, right? And again, just pick some values. We like the value of 4, right, which when I plug in the 3, it looks like I get 6 minus 4. That's not a good one. So how do I get a 4 out of this? I don't see anything really all that nice. I can make this an 8, it looks like. So let's pick a 4, okay? And then I'm just going to pick some other values. So let's pick like 7 and 10, right? We can have anything bigger than 4. These are not special values at all. I just picked them, okay? So the first one says, plugging in a 3, right? It says, if I plug in a 3 here, it says 6 minus 4, which is 2. So I'm going to do 1/2 of the log base 4. Again, when I plug in a 3, I get 6 minus 4, which is 2, plus 2, right? So again, the log base 4 of 2 is not really easy to do. So I'm just going to type in log of 2 divided by log of 4. So 2 log divided by 4 log, okay? And get my answer. And it's exactly a half, right? And so this expression right here represents a half, okay? And then I'm going to multiply by a half because order of operations, okay? And then add 2. So it looks like I'm going to get, when I do all that, 2.25, okay? So that would be when I plug in 3. When I plug in 4, it's a little bit nicer. I'm going to 8 minus 4, which is 4. Log base 4 of 4 is 1. Half of that is a half. Half plus 2 is 2.5, okay? So now I'm just randomly picked other values. So when I plugged in a 7 here, okay, I get 10. So I'm doing the log base 4. Again, the only thing that's really changing in this is that this number is going to change because I picked a different x value. Okay, and so for this problem, it's going to become 10. So again, this is a calculator problem. You're going to go to your calculator, type in log 10 divided by log 4, okay? Log 4, okay? And so that comes out to be about 1.66, and then it says after that, multiply that by a half, so times 0.5, okay? And then I'm going to add 2, and I'm going to get about 2.83, okay? And so I'll do one more. This says 10 times 2, which is 20. 20 minus 4. Well, 20 minus 4 is 16, and we actually got a nice value here. Because this is saying log base 4 of 16. Well, log base 4 of 16 is just 2. Half of that is 1, plus 2 is 3. Okay, so here's some good points. So let's again put our asymptote down, okay, which is going to be at 2, right? So I'm going to come over here to x equals 2 and draw my line. And then I'm going to graph. So we're going to put 3, comma 2.25. Okay, we got 4, 2.5, 7, 2.83, and it takes all the way till 10 before we even get up to 3. So again, this looks pretty flat, so just be very careful. It's going to be pretty flat over here, right? But it's still going up slowly. And then when it reaches here, it's going to make a sharp turn down, okay? And we're going to ride along the asymptote all the way down, okay? And again, I can confirm my x-intercept, right? 2.002. That is really, really close to this line, and that is exactly what we're seeing when we graph. Okay, so I'm going to stop this. I'm going to do all the solving and the properties in the second video. All right, so this is just all the graphing and the change of base, and then the second video we'll talk about all the properties and the solving.